In this video, we will discuss the problem find H index. Previously, this problem has been asked in companies like Google and Microsoft. So let's read the problem statement and understand the test cases here. Problem says that we'll be given an integer array which is named as citations, where citation of I indicates the number of citations a researcher got for the ith paper. Now basically, what is citation? You can basically say that citation of I is the number of times the ith paper has been talked about in different let's say organizations or at different talks. So basically citation of I indicates the quality of the ith paper. Okay, the higher the higher the citation, higher is the quality of that paper. Okay, the task is to find the H index of the citation array. So H index is the largest value such that the researcher has at least H paper that have been cited at least H times. So basically, let's understand this through some examples here. So let's say if we have one array which is based on the researcher Yash, and we have another array for citation for researcher Akshit here. Now the thing is that how can I find out the quality of the two researchers? Okay, so for differentiating between the quality or for finding out the quality, I can use the concept of H index. Now H index is basically what? H index is the largest value of H such that the researcher has at least H papers which have been cited at least H times. So they should be at least like if suppose that the H value is 1, so this means that there should be at least one paper which has been cited at least one time. Okay, let's understand this through the example of these two test cases here. Suppose if I have to think that is the H value equal to 1, okay, for this particular researcher Yash. So is there at least one paper which has been cited at least one time? Yes, there is at least one paper which has been cited at least one time. You can see here that all these papers are there which have been cited at least one time. Okay, so there is at least one paper which has been cited at least one time. So that is why H value 1 is fine. But we have to try and find the highest value of H for a given array. Okay, now if you have to think about H is equal to 2. Now is the H value 2? Because if you'll see, so are there at least two papers which have been cited at least two times? Yes, you can see here these are the papers which have been cited at least two times. So there are at least two papers. Okay, there are at least two papers which have been cited at least two times. Okay, now after that, if you see H is equal to 3, so can H is equal to 3 survive here? If you see, are there at least three papers which have been cited at least three times? So you can see here there are three papers which have been cited three or more times. You can see here these papers are there which have been cited three or more times. Correct, this paper and this paper, all these three papers are there which have been cited three or more times. So H value is 3 also. Now after that, like, can the H value be 4? Think about it. Are there at least four papers which have been cited four or more times? Four papers are there or not that have been cited four or more times? No, there are not. We do not have four papers which have been cited four or more times. So that is why H is equal to 4 is not possible, and higher values are also not possible. So that is why the H index for the researcher Yash will be how much? It will be 3, because the thing is that there are only two papers which have been cited three or more times. Okay, now after that, let's look at the quality of the researcher Akshit. So if you see researcher Akshit, so H value 1, is it possible? Is there at least one paper which has been cited one time? Yes, you can see all these papers have been cited at least one time, so H value 1 is fine. Now let's think about H is equal to 2. So H is equal to 2. Are there at least two papers which have been cited at least two times? So yeah, you can see here all these papers have been cited two or more times, so that is why H is equal to 2 is also acceptable. Now when the H value is 3, are there at least three papers which have been cited three or more times? Yes, you can see here that there are four papers which have been cited more than three times, so this is also fine. Now if the H value is 4, is it acceptable? Are there four papers that have been cited four or more times? Yes, there are four papers which have been cited four or more times, so H value 4 is also fine. But H value 5, no, because there are, like, in this array we do not have five papers which have been cited five or more times, at least five or more times. So that is why for the researcher Akshit, we'll have the H value as 4 only, because there are four papers which have been cited four or more times. Correct. So who is a better researcher amongst Akshit and Yash? The better researcher is basically Akshit. Why? Because the thing is that he has got higher value of H. Okay, so his H index is higher here. I hope you have understood the H index concept. Now, how do I find H index here? So there are multiple ways of finding it, but one of the very basic and the brute force approach would be to sort the array. So let's discuss the approach here. Okay, so let's see the input here as well. So let's discuss the couple of more inputs so that we can apply brute force to them as well. So if you see here, suppose that if I have got 5 0, then 2 and then 0 and then 2. Okay, so if you think about H value as 2 here, are there at least two papers which have been cited two or more times? Yes. Can the H value be 3? No. Because are there three papers which have been cited three or more times? At least three or more times? No. So that is why the H value will be 2 for this particular test case. If you will think about the next test case, that is the second test case here given. So what is it? It's basically 6, then you have got 0, then you have got what? 3, then you have got 5, and then you have got 3. So let's say if H value is 3 here. So are there at least why is the H value 3 here? Because there are at least three papers which have been cited three or more times. Can the H value be 4? No. Are there four papers which have been cited at least four or more times? No. So that is why the H value for the second input will be 3 here. Highest H value will be 3, H index will be 3 here. Okay. Now, how will the brute force approach work here? So basically, you can understand that we can basically try to sort the array in the decreasing order. So if we will sort the array in the decreasing order first of all, so we'll get 6, 5, then we'll get 3, then we'll get 3, and then after that we'll get what? We'll get 0 here. Okay, so this is the array that we get. Now, why are we sorting in decreasing order? Because we'll try to iterate starting from this particular index here. Okay, what will be the advantage of that? So we will get to know that we will basically first of all try to be on those papers which whose value can be greater than the index. So right now if you will see, basically what will happen, if you will see here, let's say if I am at this particular index, so I value will be 2 here. Now the value index is 2 here, and the element at this particular index is 3. So since 3 is greater than the index 2, because you can say that citation of I, it is greater than what? It is greater than the index. So this means if I am at this particular index and the citation of I, if it is greater than the ith index itself, so this means that there will be at least I plus 1 paper. There are at least I plus 1 paper that have citation greater equal that have citation at least I plus 1. Okay, because if you'll observe here, all the papers on the left side of this index are having citations greater, because we have sorted the array in the decreasing order. So elements on the left side for any particular ith index, the elements on the left side will have higher citation value. Correct. So if I'm at this particular index and this particular index element is having value more than the index, so this means that on the left side all the other paper also have value greater than this particular index. So if the index is 2 and the citation here is 3, so citation is greater than the index. So this basically indicates that there are, for this particular case, there are at least 3 papers on the left side that have citation greater equal to 3 here. Okay, so that is why we have sorted in the decreasing fashion, because whenever I am at a particular index, I know that all the elements on the left are greater than the ith element itself. So we just have to check the ith element whether it is greater than the value of I or not. If the ith element, if the citation of I is greater than the index itself, if the citation of I is greater than I, this means that there are I plus 1 citations that have passed the criteria here. Okay, so let's understand this by doing the proper dry run here. So what will happen here is, initially my index will be where? Initially my index will be standing at 0. Now I'll check, is the citation at this particular index, is the value at this particular index greater than I itself? So if you see 6 is greater than 0, what does this mean? So this means that the number of times this paper has been cited, it is greater than the index. So this means that there is one paper okay, which has been cited at least one time. Okay, so we can move forward, because we have to try and find the highest value of H here. Now after that, we'll do what? We'll come to the next index. When we come across the next index, the index is basically 1 here. Now when I come across this index, so the value at this particular index is greater than the index itself. Okay, so this means what? Since 5 is greater than 1, so this means that 5 is greater than 1, so the index is 1 here. So this means that there and the criteria of citation of I being greater than I is followed here. So this means that there are 2 papers which have been cited at least 2 times. Okay, so two or more times basically. So that is why at least two or more times. So that is why what we can say here is we can say that this is also fine. So we can move to the next index. Basically, if for a particular index the criteria is satisfied, then this means that I plus 1 is the number of papers that are satisfying the criteria. Now after that, like when we'll move to the next index, so let's say my index will be 2 here. Now is the citation greater than the index? Yes, the element at this particular index is 3. 3 is greater than 2. This means what? This means that there are at least 3 papers, okay, which have been cited 3 or more times. Correct. So that is why this is also fine. So I index is at 2, which is acceptable here. So you can say that this is also fine. But after that, like when my index will move to the next element, that is when I will be at this particular element here. So the value here is 3 as well as my index is 3. So citation is not greater than I. Now what does that mean? Because index it is at 3, this means that there are 4 elements here. Okay, so there are 4 elements. So like and this particular element is not greater than I. This element should have been greater than I. It should have been at least 4, but it is 3. So that is why I'm checking for the greater than sign, because the element at the ith index needs to be greater than I, because if it is not, then if I'm at the ith index, so this means that I'm checking for I plus 1 publication research papers here. So that is why since the citation of I is not greater, so this means that there are not since the I value is 3 here, so there are not 4 papers which have been cited at least 4 times. So that is why I can stop here, because here the criteria is not getting followed, and we can simply print the value of I, because I value will indicate that how many papers were able to satisfy the criteria. So there are 3 papers. Since the I value is 3, it indicates that there are 3 papers which have been cited at least 3 or more times here. I hope you have understood this much part. Now, if you see, we are sorting the array in the decreasing order. So that is why it will take how much time? It will take order of n log n time, because we'll be sorting the array. And then another order of n time will be taken because we'll be iterating throughout this array as well. And if you will think about the space complexity of my code, it will be basically order of 1 here, because I'm not going to use any extra space for applying this approach. Okay, so you can see here, naive approach. So simple approach is to sort the array in the decreasing order, and I've told you why we are sorting in the decreasing order. Initialize the index at 0, I value at 0. Okay, then what you have to do is you have to find the h index. So you'll iterate from the left to right direction, and if the citation of I is greater than the index itself, then this means that all the paper from index 0 to from 0 till index, they have at least been cited I plus 1 times. That is what I had shown you during the dry run. Okay, we keep on incrementing the index if this criteria is getting followed. If we reach the end of the array, then we can stop, or whenever the criteria is not getting followed, then we can stop here. Whenever there is any index for which the citation is less than equal to the index, then we can stop there. Okay, let's have a look at the implementation, how we'll implement the brute force code. So basically what we will do is, first of all, we'll sort the given array in the decreasing order. So I'm using reverse is equal to true in Python here. You can code respectively in other languages. Now after that, what will happen is your length will be taken for this particular array, and index will start from 0. In my dry run, I was taking I is equal to 0. Here we have taken index is equal to 0 variable. Okay, now after that we'll iterate until we reach the end of the array. Okay, and the condition is that for any particular ith index, the citation of I should be greater than the index. If the citation of I is greater than the index, then we'll keep on moving further, and at the end, whenever the loop will stop, then we'll return the index, because in our dry run also you can see that for the third index the condition was not true. At the end, we'll return the index 3. This indicates that there were at least 3 citations like 3 papers were there which have been cited at least 3 times. Okay, so this is what we have done in the brute force code. But the thing is that we are sorting the array, so that is taking a lot of time. Can we do it in linear time complexity? Yes, we can do it in linear time complexity as well. How? So let's understand that. So in the optimal approach, what we can do is we can use the concept of count sort. Okay, now what does this mean that we can use the concept of count sort? So basically, by using the concept of count sort, what we will be doing here is we'll be counting. Okay, we'll store the frequency of all the citations. Now if you see here, what does that mean? So you can see here that if this particular if you see in the citation array, so we have got 3 2 times. Okay, so at the third index we have updated the frequency as 2 here. Why did we do that? Because like frequency of 3 is equal to 2, what does that indicate? If the frequency at the in the frequency array, if we have the value 2, what does that indicate? That there are there are two papers which have been cited 3 times. That is what it indicates. Now if you see here, another thing is that we have declared the frequency array, which is basically equal to n here. Now in this case, since we are having frequency array same as the size of the citation array, because if you see, why did we declare the frequency array as the same as the size of the citation array? Because suppose if the citation array was given something like this, if we had the citation array, and suppose that maybe one particular entry was, suppose that we had 5 citations here. Let's say we had one, we had let's say other entries were 444, something like this. Okay, so let's update the values like this here. Suppose this was the array that I had. Now this is the citation array, suppose. Now the thing is that why did we not declare the frequency array of 100 size? Why? The reason is because, think about practical terms. The size of the array is how much? The size of the array is basically 5. So there will be not more than 5 papers. So the h value for this particular array can never be 100. Understand this thing very clearly. H value of this particular citation array can never be 100. Why it can never be 100? Because you should have 100 elements for it. You should have 100 published papers for it. But you have only 5 papers. If you have only 5 papers, then how can you say that 100 papers are there which have been cited at least 100 or more times? Okay, so that is why you do not need to declare the frequency array of 100 size. You only need to declare the frequency array of n size, because in the best case, what can happen for any citation array? Let's say the citation array is having 5 size, so there can be 5 papers which have been cited 5 or more times. Correct. So in the best case for any given array, the highest value of h can be the size of the array itself, not more than that. Because if you will hypothetically give me an element 100 and ask me to declare ask me to declare the h value as 100, that is not possible. Because if you are giving me the size of the array as 5 and you are giving one of the values as 100, then this doesn't mean that there are 100 there can be 100 papers that have been cited 100 or more times. So that is not true. So that is why the frequency array should be same as the size of the citation array. Okay, so we have declared the frequency array till the index 5 only, because in the best case what can happen, so frequency array will be of n plus 1 size, because the array will be based on 0 based indexing here. So the thing is that for this particular purpose you only need to declare n plus 1 size frequency array. I hope this is clear. Now after that, if you'll see, so we'll basically iterate. Now you will ask me that suppose that if I had this array and if I had 100 here, and then rest of the elements were basically, let's suppose 444. Now since the size of this citation array is 5, then basically since the size is 5, so we'll have the indexing from 0 till 5 here. Correct. Now you'll ask me that suppose if I have citation 100, so where will I store the frequency for the citation for this particular paper which is having citation 100 here? So if a paper is having this much citation, so I'll store it at the last index, that is the 5th index, because it will be considered in the case which this paper will be considered in the case which has been cited 5 or more times. So that is why I can save myself from getting overflown also, because if I try to store this 100 at the 100 index, that is not possible. So if there is any citation which is greater than n, so we'll store it at the last index itself. Okay, if there is any citation which is greater than n, store it at the last index. So if 100 is there, store it at the 5th index. So that will indicate that this fifth index, last index 5 with respect to n is equal to 5 will indicate the count of the papers which have been cited 5 or more than 5 times. Okay, so I hope this makes sense. Now after this, if you'll observe here, so what will happen is we'll update the frequency array. How? So firstly we'll come across this guy 6. Now since it is greater than n value, because the size of the array is 5, so we'll update it at the last index. So at the last index, one count has been updated, remember. Okay, then after that 0 is there, so update it at the since you have 0, so update it at the 0th index. Okay, then after that you have got what? You have got 3, update it at the index 3. Okay, then you have got 5, update it at the last index. So the frequency of the last index becomes 2 here, because at the last index you're storing the papers 5 and 6, so 2 papers are getting stored, because 2 papers are there which have citations 5 or more. Okay, then 3 is there, so update it. So that's how the frequency array gets updated. Now after that, we'll iterate from the backside. Why will we iterate from the backside? Because again here we'll use the concept of the decreasing array. How? Because suppose if I'm standing, suppose in the frequency array, if I'm standing at the index 3, Okay, if I'm standing at the index 3 and I see on the right side. So what do I see? Like I see that I have got a 2 here and I've got a 2 here. So if I'm standing at the index 3 and if I iterate from the right side, suppose if I iterated from the right side, so far I can see that on the right side I had seen 2 already and now I'm seeing 2 as well. So this means that when I'm at the index 3, so there are 4 papers which have been there are total how many papers? There are 4 papers which have the citation greater or equal to 3 here. Okay, because now now the indexes of the frequency array are going to tell me about the citations mean what? Citations means the quality here. Okay, and these numbers will tell me about the quantity, that which citation is present how many times here. So now if you will see here, we'll start from the last index, because obviously our goal is to try and find the highest value of h here. Correct. So initially we'll start from the last index, okay, with the largest possible value of h. Okay, and the counter will be initially equal to what? Counter will be initially equal to 0 here. But when we come across this element, okay, then my counter will become equal to what? When I come across this particular element, then my counter will become equal to 2 here. So what does this mean? That there are, if I'm at the index 5, so there are, and the count is 2. So this means that there are at least 2 papers, there are at least 2 papers which have been cited, here. So yeah, when I'll start, then the count is basically equal to 2 here. The count is equal to 2 means that there are 2 papers which have been cited at least 5 times. Correct. So as of now, if I'll see this particular index here, so the thing is, the issue is that I want the citation 5. So are there 5 papers which have been cited at least 5 times? No. So that is why this index does I'm not getting satisfied here. Why? Because my count is 2. So since my count is 2 only, so there are only 2 papers which have been cited 5 or more times. But I wanted at least 5 papers since I'm at the index 5. So I would have liked that there are 5 papers which have been cited 5 or more times. But that is not the case. So this index will not be my answer. Then after that, what will happen? I'll go to the next index. I'll move one step down, and when I'll go to the index 4, still my counter will remain the same because I'm not getting any value at this index 4. So my count is still equal to what? 2. Now what does this indicate? Now if my count is still 2, so you can observe here that since I'm at the index 4, so how many papers are there which have the citation which have since I have I'm at the index 4, so this means that there are 2 papers which have been cited 4 or more times. Okay, but I needed how many? I wanted that 4 papers should have been there in order that 4 was the answer. Since I wanted 4 as the answer, so for that I wanted the count to be equal to at least 4. There should have been 4 papers which should have been cited 4 or more times. But I am having the counter value as 2. So this means that there are only 2 papers which have been cited 4 or more times. Correct. So this cannot be the answer here. So I'll say that, okay, let's move to the left index. Let's decrease the I value. So yeah, when I come across this index, now my counter becomes equal to what? Now my counter becomes equal to 4. And I'm at the index 3. So this indicates what? That there are 4 books which have been cited at least 3 times. There are 4 books. Okay, how many books are there? There are 4 books, or you can say 4 papers, 4 research papers are there which have been cited at least 3 times. So does this satisfy the criteria? Yes, this satisfies the criteria. So that is where I'll stop, because I want the highest index that satisfied. So this index satisfies my criteria. So that is why my answer would be finally 3 here, and I'll stop my loop here. Okay, so I hope you have understood the criteria here, like for solving this problem. Now let's have a look at the code as well. So if you will see here, as I said, like you will declare the frequency array for n plus 1 size. Why? Because if the n value is suppose 5, then you need to have the frequency array from the index 0 till 5, that is n plus 1 size array. Why? Because in the best case, what can happen? 5 books can be there which have citations which have been cited 5 or more times. So that is why you need nth index as well. So you will declare the frequency array of n plus 1 size. Now what you will do is you will iterate in the citations array, and you will check if the ith citation is greater or equal to n. So for any citation that is greater or equal to n, you will store it at the last index. That is what we have discussed. Okay, then after that, for other citations which are basically less than n, you will store them at their indexes directly. And then after that, you will start your index from n value. So you'll start your index from the last. So in idx variable will be equal to n initially. Then after that, like initially the sum will be equal to the element present at the last index. Then after that, you will iterate until when? If the sum value, if basically the sum, or you can say the counter, in my code I was using the counter, you can say that is nothing but s variable here in the code. Okay, so if the s value, or you can say that counter, if it is lesser than the index, okay, if the counter is lesser than the index, if the sum or the counter is lesser than the index, so this means that there are lesser citations compared to the index. So that is why we need to keep on decreasing. Okay, but whichever index, whenever an index satisfies, that is when the loop will stop. Because if at any point of time, according to my dry run, if the count was greater or equal to the index, or you can say that if the s is greater or equal to I here, okay, then you can stop there, because that index will be your answer. For example, for this particular index, the s value is what, 4 here, and the index is basically 3. So whenever the s value is greater than equal to I, then you can stop here. So otherwise you need to keep on decreasing, and you need to keep on adding the frequency of the index one by one. Okay, frequency at the index. Now after that, at the end, you will return the I value. So this is how your code will work. Now, what is the time complexity for this particular approach? The time complexity taken for this particular approach would be nothing but, you can say, order of n. Why? Because like we are just doing what? Firstly, we are running one loop here for iterating throughout the citations array. Plus, you can say that we are running, in the worst case, we are running another order of n time using the second while loop here. So this is overall order of n only, right? And space complexity is how much? Space complexity is order of n, because we have declared one frequency array of n plus 1 size. So the space taken will be order of n here. And this is much more optimal approach. This question previously has been asked in companies like Google and Microsoft. So I hope you have understood the logic for it. Let's quickly submit the code. Let's try and write the code and submit it to see if it is getting accepted or not. So let's now try to submit the code. So you can clearly observe that the code is getting accepted. I hope you have understood this clearly. Please make sure to comment understood. Thank you for watching this video.